Hi everyone, welcome back to my YouTube channel. We'll continue with question 6 of GCE Advanced Level Maths Paper 2 2023. In this question 6, Roman 1, it says solve the differential equation dy dx is equal to x e to the power 2y, given that y equal to 0 when x equal to 0, expressing the answer in the form y equal to a function of x. Now when you are going to solve a differential equation, whenever you want to solve it, you are going to solve it using separation of variables. It means all like these variables in terms of y will go this way, and we're going to have e to the 2y, then the variable dx will also go that way, which will give us the integral e to the negative 2y dy equal to s ds. This integral, when you integrate negative 2, remember 1 over, from indices, 1 over a to the power n is a to the negative n. So this, you differentiate that, it will be negative 2. So our answer here is e to the negative 2y divided by negative 2. And here is x squared over 2 plus k. Okay. But now, the initial conditions, 0, 0. So that we obtain the value for k. So we have e to the power 0 over negative 2 is equal to 0 over 2 plus k. And this gives k will be negative half. Okay. Now, that's said, so we can write this one back as this equation back as negative 2y over 2 is x squared over 2 plus minus half, multiplied 2 throughout and negative. We have e to the negative 2y is negative x squared plus 1. Okay, now to write it in the form y equal to ms f of x, this e, if you take ln of both sides, we are going to have negative 2y, because ln e, ln will be ln e, negative 2y ln e, which is 1, is ln 1 minus x squared, which give us y will be equal to negative half ln 1 minus x squared. Once that is done, means you have written it the form y equal to f of x, because this is our function y, which is a function of x there. Okay, that's it. We go to the next question. This says a relation R defined on the set S is given by R is 1 1 1 3 2 3 3 1. Show that R is an equivalence relation. B, the equivalent classes of 1 and 4. Okay. Roman 2a. To first of all show that it is an equivalence relation means we need to verify reflexivity, we need to verify symmetry. Okay, in that relation. Now, that relation is reflexive. It's reflexive in the sense that we have there with us, we have 1 relating 1, we have 2 relating 2, we have 3 relating 3, and we equally have 4 relating 4. So it is reflexive. We need to look at the symmetric property. in terms of symmetry. Now, When you look at that relation, you will see that we have 1, 3 and 3, 1. You can see 1, 3 and 3, 1. 1, 3, that is 1 relates 3, and at the same time 3 relates 1. Remember that a relation R is reflexive under a set A if for all A, B belongs to A. If A relates B, then B should relate A. Okay? And that is it. For it's symmetric, it's symmetric. If A relates B, then B relates A. For reflexive, A relates A related to itself. Now we're going to look at the third property, which is transitivity. The transitive property means we have A, B, C belonging to the set that has been defined. If A relates B and B relates C, then we show that A relates C. That's a transitive property. So from that set, we have 1 relates 3, and we equally have 3 relating 1, and 1 relating 3, 3 relating 1. Here we have 1 relates 1. This implies it is transitive. Okay, this implies that R is transitive. Okay, now having looked at that, we can now conclude that hence it is an equivalence relation because it is reflexive, it is symmetric, and it is transitive. We must always conclude. Now if you are asked to show that a relation is not an equivalence relation, you can feel free. Once one does not hold, you just stop there. You show that it is not reflexive, allez, continue. Any condition that fails, you don't need to waste your time. Now the other part is we are asked to look for the B part. We are asked to look for the equivalence classes of 1 and 4 under that relation. Now when you talk about the equivalent classes of 1, it means those which are related to 1 in that, and those which are related to 1 in that set, the equivalence classes will be what? 1 and 3. Because we have 1, 1, we have 1, 3. And that of 4, the equivalence classes of 4 will be 4. Since we have what? 4, 4, which belongs to R. So those are the equivalence classes, those sets which are related to 1 with respect to that relation. Okay, that said, we'll go to question 7. Okay, we have question 7 here with us. Question 7, Roman 1. Question 7 here says we should show that f is bijective. 5 marks. And for us to show that a function is bijective, it means we need to show that it is injective and surjective. Injective and surjective. Okay, if it is both injective and surjective. Now for injectivity, let's start by proving injective. Let's verify injectivity. Okay, now you see that for us to prove that it is injective, if you have f of A equal to f of B, injectivity is just like being like it's a one-to-one mapping. If you have, what is it talking about? Be injective means that you are assuming that you have two elements A and B in a set in the domain, now for which their images are the same. But if you succeed to arrive at the conclusion that their images are the same, hence it means that they are the same element, that's A is equal to B. It means it is injective, it is a one-to-one. Okay, so we assume f of A equal to B. What does that mean? This means A, the function is x over x plus 3. So we have A over A plus 3, B equal to B over B plus 3. Here implies that we cross multiply here, we are going to have A into B plus 3 is equal to B into A plus 3. This gives us AB plus 3A is equal to AB plus 3B. AB minus AB here gives 0. You're left with 3A is equal to 3B. This implies A is equal to B. Hence, that function is injective. Okay, it's injective. Now, let's verify surjectivity. Is the function surjective? So to verify surjectivity, it means you need to verify, the fastest approach is to check if the domain of F inverse is equal to the domain of F. If the domain of F inverse is equal to the domain, the domain of F inverse is equal to the codomain of the function itself. So we need to start by obtaining F inverse. Now, to obtain the inverse of F, we say let f of x equal to y. This implies x over x plus 3 is equal to y, which implies x is equal to xy plus 3y. We are making x the subject here. We have x minus xy is equal to 3y, which implies from here we have 1 minus y is equal to 3y, which implies x will be 3y over 1 minus y. So our F inverse will simply be 3x over 1 minus x. Okay, 3x over 1 minus x. Are we there? All right. So that's it. What then is this domain here? The domain of F inverse is, if you look at the denominator, you set this to 0, x will be 1. So it's a set of real numbers excluding 1. And when you look at the question itself, let's look at the question itself. You see that the, yes, good. You see that the codomain, this is a codomain here, r minus 1. So thus, which is equal to the codomain of f. Hence, F is surjective. And you conclude now that since F is both injective and surjective, therefore it is bijective. That is bijectivity. Okay. Now we have the Roman 2 part. Given the periodic function f with period 6, have a periodic function f with period 6, where f of x, okay, anyway, permit me right here so that we analyze the function together. Please permit me right by this side. Normally I'm to go right down, but I want to show certain key things about this function. So permit me right solve. Yeah, not to do this the best way is down. but I want to be studying the function while you are seeing. Given the periodic function f with period 6, the period of that function 6 means it repeats itself. The function will repeat at intervals of 6. Now we are told that show that it is not continuous at x equal to 5. To show that it is not continuous, we have the limit to the left, okay? That's, you have limit at x tends towards 5 above of f of x. X tends towards 5 above, okay? If it's above, we have here, this is the above, this one, this range. It means you substitute there, x will be negative half times what? 5 plus 4. That's negative 5 over 2 plus 4. That's negative 2.5 plus 4, which is 3 over 2. Now we check as x tends 5 below. From below here, 5 we are substituting here is 3 minus. Remember, this is our 5 here, this is 5 here. It gives us 5 minus 2 gives us 3. So the function is not continuous because the limit by the left is not equal to the limit by the right. So it is not continuous. Okay. Now in the B part, we are asked to obtain f of 19. When the function is given in the period 6, it means f of 19. When you look at this range, do you see any 19 there? Because you are substituting by the values in this range. No, you don't see any 19, right? Okay, yes, the other person says it says 19. Okay, now how then do you use the aspect of the periodicity? If it is periodic, means you write as multiple. Multiple of 6 plus which number will give us 19. That falls in that range. You will notice that f of 19. How can I write 19 in terms of multiples of 6? As a period means multiples of that. I can write 19 as 6 times 2. Okay, it will be, if I say 6 times 3, it will be 18 plus 1. Oh, but 1 is not in that range. 1 is not between 2 and 5. So 6 times 2 will be 12 plus 7. Okay, 7 is in the second range between 5 and 8. So this means f of 19 is simply the same as f7. And which range do we have between 7? 5 to 8 is this. It means you substitute here. So we have negative 7 over 2 plus 4. Negative 3.5 plus 4 is half. So f of 19 is half. Okay. F of 19 gives us half. Now, having done that, we are asked to sketch the graph. Sketch the graph of y equal to f of x in the interval negative 1 less than equal to x less than equal to 1. Okay, now we are asked to sketch it in that interval. Anyway, since this has been explained, I would like to, this has been explained already, I would like to erase it so that I use that space. I want to explain that particular function following that range so that we really grab it well. Okay, so this is what we are going to do. Okay, let me erase this. Let me erase this and Okay, now having done this, let's say sketch the graph of in this interval. In this interval means you have -1. You will see that f of -1, there's nothing here in that range. That negative, you write the period is 6, -1 plus 6. It gives us 5. So we have f of 5. Is there a range there? Yes, it's up above and below. We have two values. If it's strictly 5, it will be 3. For strictly 5 it will be 3. For strictly the other one above it will be 3/2. So that it will help us. Okay, then we'll go to 0. 0 is not in this range. So if you see that for 0, f of 0 after -1, 0 is not in this range. So it's 0 plus 6, right? Because the period is 6. F of 6 is, it will fall in this one. 6 is between 5 and 8. So you have -half times 6 is -3 plus 4, 1. So f of 6 is 1. Likewise, that's 0 is f of 6. Likewise, f of 1 will be f of 7, right? 1 plus 6, 7, which is still be -3.5 here. If you put -7/2, -3.5 plus 4 gives us a half. And likewise, f2. I just want to use this to show you how to obtain the various values using the period. F of 2, good, is here. So it will be 2 minus 2, which is 0. And f of 3, yeah, is 1. f4, correct, 2. f of 5, we've already obtained it there. 5 is 1, and also 5 is is 3. F of 6, yes, we already obtained it. So you see that it starts repeating itself. F of 6 is f of 0. F of 6 is f of 0, which is 1. F of 7 also, which was obtained, which is the f of 1. F of 7, half. F of 8, 0. Okay, because 8 is here, -half, so f of 8 is 0. So when you have this, even from the period, when we are to draw this, when we are to have our sketch, okay, when we are to have our sketch, if you are to have our sketch of this, this is what we are going to have. Now we have here -2, 2, we have here 0, we have 4, 6, 8. Then we have our y-axis here. We have here 1, 2, 3. Okay. Now you notice that when we had -1, our answer was 3/2 for the first case. As we had 3/2. Okay, we had 3/2 above. We had two values. -1, we had 3/2, that's 1.5. -1, 1.5. And we equally had that same -1. I would like to use a circle. Why? Because to show that that -1 had some values. We had 3/2. 3/2 was there at the point when, for 3/2, we had it but the down part here. So you see that there's no circle, there's no equality sign there under 5 in that case. So for -1, 3 over 2, we put a circle here, and equally -1 we had 3, which 5 was included there. That one we can shed, because why are we shading here? Let me scroll again. If you look at this function, you see here in this interval the other 3 is here, 3 is here, less than equal to. Okay, this should be on the same line. And then if you continue with -1, after -1 we have 0, 0, okay, we have 0, 1, 0, 1, yes, there was 0, 1 here. Then we equally have 1 and 1 going with half, is 1 with half, sorry, 0, 1, 1 with half, and it continues like that to 2, 0, 2, 0 here. So by linking this from here to here, you link your straight line here. Then from here we equally have 5, okay, 5, 3, 5, 3. So we link from here, 5, 3, we link to here, 5, 3. Then at that same 5 again, we had 5, 1.5. This is here, 5, 3. 5 is on 2 sides. 5, 1.5, 5, 3, 5, 1.5 for the open here. And we have here 8, 0. 8, 0. We end with 8, 0 here. That is our periodic function. Okay, hope that is very okay. Okay, that said, we'll go to question 8. Okay, looking at question 8 here. Looking at question 8. In question 8, Roman 1, show that a root of the equation this lies in the interval -1 and 1. -1, 1. 3 marks. Okay, to show this is simply that for a root to lie in this interval means there should be a change in sign. Okay, because the root is 0. So I have to substitute -1 in this function. When I substitute -1 in this function, because first of all, the first thing is that this f is a polynomial and hence is continuous. Polynomial functions are continuous. It's a polynomial and thus it is continuous. Continuous in R. Okay, now so we have that function. Let's obtain f of -1. F of -1 means -1 there cube plus -1 square plus 3 into -1 minus 2. This is -1 plus 1, 0. -3 minus 2, -5. Now f of 1 cube plus 1 squared plus 3 into 1 minus 2, 2, 5, 3. So since f of -1 times f of 1 is less than 0, hence we say a root lies in that interval, because there is a change in sign. You cannot leave from negative to positive without passing through 0. So there must be a root in that interval. Okay. Okay, that said, let's look at let's solve Roman 2. Roman 2, we have a line. Show that the point P, remember this L is a line. That's the vector equation of a line. We have a vector equation, we have the Cartesian equation. Now the vector equation of a line. The vector equation of a line, I want to show that it lies on this line. We are going to substitute to verify this. Since that one is the vector equation, when we have arrow is 3i minus j plus 2k plus lambda I plus j minus k. Okay, let me just copy pi. The plane is x minus 2y plus 2z is equal to 3. Show that 2, negative 2, 3 lies on that line. 2, negative 2, 3. From this vector equation of a line, in Cartesian form we have x, y, z. We have 3 here, the j negative 1, the k 2, plus lambda 1, 1, negative 1. Okay, now if the point is on the plane, 2, negative 2, 3, 2, negative 2, 3, if it's on the plane, means it satisfies this. Those are the coordinates. 2, negative 2, 3 is equal to 3, negative 1, 2 plus lambda 1, 1, negative 1. Since it satisfies that plane, 2, negative 2, 3. Okay, let's verify that. So we are going to have 2 is equal to, you compare the component 3 plus lambda. And when we solve lambda here, lambda is negative 1. Negative 2 is equal to negative 1 plus lambda. And when we solve for lambda here is negative 1. 3 is 2 minus lambda. And when you solve for lambda here, lambda is equal to negative. You see that it's consistent. The value of lambda is uniform. It's constant. It's uniform. And with this uniformity, it tells us that that point belongs to that line. Okay, so that point belongs to that line. All right, I would like us to look at this is the position vector of the point of intersection of the line and the plane. 4 marks. Line and the plane. Line and the plane. If the line is intersecting with the plane, okay, it means we have here, these are the various x coordinates which should just be substituted in this plane, and we obtain our value of lambda for which they are intersecting. Because when they are intersecting, it means that their coordinates are the same at that place, which we are going to substitute here to have. So x now will be as 3 plus lambda. Substituted in the plane, we have 3 plus lambda minus 2 into the y component, negative 1 plus lambda, plus 2 into z, the z component, 2 minus lambda is equal to 3. Okay, now we solve for lambda here. Lambda gives us 2, so the value of lambda is 2, for which the plane is intersecting with this line. This is that line now from vector form to Cartesian form. So the position vector of point of intersection, what then will it be? The position vector of point of intersection, if you substitute here, you will notice that that point of intersection will become that point of intersection will give us, if you put 2 here, it will be 3i plus 2 will be 5i. If you put negative j plus, will be negative j, right? A negative j plus 2j will be j plus j. 2k minus 2k 0. So that's the position vector of the point of intersection, 5i plus j. 5i plus j. That's the position vector of that point, having obtained your lambda. Okay, Now the next part of that question is determine the sine of the angle between the line L and the plane. Between L and the plane. So what are the things that we need? Sine theta. We need the normal to the plane and the direction vector. Okay, the normal and the direction vector. N dot D over N. So the normal to the plane. How do you obtain the normal to the plane, my dear students? The normal to this plane is simply the coefficient of x. So it will be I here minus 2j plus 2k. That's the normal vector to that plane. The coefficient of x there. Okay? That gives us the normal vector. Okay, talking about this, that's the sine of the acute angle. The normal to the plane, just to emphasize, is the coefficients of x, y, and z. That's 1i here, negative 2j plus 2k. That's the coefficient. And the position vector of the vector equation of a line, I plus j plus minus k. That is what we use to obtain this. Okay, that said, let's go to question 9. Okay, looking at question 9, given that we have that, find the value of x. When you look at this, what do you notice? Yes, what do you notice when you look at here? What do you notice about this? You notice that it is going, you have 3 dots, means that it is infinite. And when you see addition, what does that mean to you? Okay, it means sum, right? So that's the sum of what is infinite. We are talking about the sum to infinity. So the sum of what is infinite is a sum to infinity. Okay. So what is our sum to infinity? Our sum to infinity, and you look at it, you see there is a GP. So 1 minus r. We are talking about a GP in a sum to infinity. Okay. And we know it converges. It converges when the magnitude of r is less than 1. Okay, so that approach can still be used. So if you are to solve it here, our r in this case is, you look at this term, x over 2x minus 1 squared divided by x over 2x minus 1. It will still give us x over 2x minus 1, and that our a will be the same. So sum to infinity, it means we have x over 2x minus 1 divided by 1 minus x over 2x minus 1 equal to what? 3 over 4. Okay, so when you have that, when you simplify 1 minus x over 2x minus 1, when you simplify this, that's 2x minus 1 times 1 minus x there. Okay, when that is simplified, we have 4x is equal to 3x minus 3, which gives us x as negative 3. So the value of x is negative 3. Now, Roman 2, a linear transformation is represented by the matrix A, where A is that. Find the image of the point negative 5, 2, 1. Negative 5, 2, 1. The image of the point, anyway, let me maintain so that we see here. The image of negative 5, 2, 1 under t means we are going to take to answer that question of Roman 2. Okay, means we take that same matrix 1 2 3 2 4 5 3 5 6, you multiply by negative 5 2 1. Now when you are multiplying by negative 5 2 1 is the image of that point. If the answer said the image was that, and find the object, the point, you take the inverse, you multiply by the image to find the point. So we have this 1 negative 5 plus 2 times 2 here, take the row, multiply, 2 negative 5 plus 4 negative 1 plus 3, it gives us 2. Likewise you do same here, it gives 2 3 1. So the image of negative 5 2 1 is 2 3 1. Now we are given another matrix B. Find the matrix product BA. Okay, find the matrix product BA, that's Roman 2b. The matrix product BA. BA, here we have our B, 1 negative 3 2 negative 3 3 negative 1 2 negative 1 0 times A, 1 2 3 2 4 5 3 5 6. Okay, let's multiply. Take the row, multiply by the column. Sorry, there's a 2 here. So 1 times 1 here is 1. Negative 3 times 2 is negative 6, plus 2 times 3 is 6. So 0. 1 minus 6 plus 6 is 1. So we have 1 here. Likewise, you multiply, follow the same procedure. You have 0 1 0 here, 0 0 1. Now what does that tell you? You have taken a matrix B, you have multiplied A, and it has given you a matrix which is the identity matrix. It means this B is A inverse. This simply means B is equal to what? The inverse of A. When that happens, when you take a matrix, you multiply by its another one, it gives the identity, means the other one was the inverse. So that is the inverse of that matrix. Hence or otherwise, find a point where the three planes with equations intersect. Okay, where these three intersect is simply talking about, after finding the product, you have the inverse. Where they intersect is simply solving these equations, right? Okay, you are solving it. If you look at it well, you see the coefficients here. Coefficient of x is 1 2 3. Okay, so you are simply using that inverse, then you multiply by 5 9 12, will give you the point where they intersect. Alright, that's to have that point of intersection is simply the solution of those three equations. So you take our inverse, which we obtain as 1 negative 3 2 negative 3 3 negative 1 2 negative 1 0. I will multiply by that point 5 9 12. It gives us 1 times 5 plus negative 3 times 9 plus 2 times 12. It gives us 2. And the same way, this times all of this gives 0. Then this times 2 10. 10 minus 9 1. plus 0, 1 here. So the point of intersection is, as a vector form, as a point 2, 0, 1. That's our point of intersection. Alright, that's it. Let's go to question 10. Okay, now let's go to question 10, the last question. 10 Roman 1 here says, show that the expression x squared plus 2x plus a is positive for all real values of x. It is positive for all real values of x. Now, it is positive for all real values of x means what we can use is a quadratic, so we'll resort to using completing the square, right? So x squared plus 2x plus 6. By completing the square, first thing is to make sure that the coefficient of x squared is 1. Now that is 1, no problem. We'll go straight away. X squared plus half the coefficient of x, that's 1 squared. I'll add it and I will subtract since we are on the same line, plus 6. Okay, plus 2x. Let me write it clearly. Okay, I'm saying we have x squared here plus 2x plus half it is 1, right? Half I subtract plus 6. So all of this is x plus 1. When you do that, all of this is x plus 1 all that square. Negative 1 plus 6 is plus 5, which is always positive, right? Because no matter the value of x plus 1 will be squared. And when you add 5 to a positive, it will always be positive. You say, hence, find the set of values of x for which you have inequalities there. For which we have this greater than 3. Okay, I still wish to reiterate here that for you to solve an inequality, a rational inequality for that matter, solving inequality, you don't cross multiply the variables because you don't know the value. Okay, you don't know the value of x. You don't know whether it's a positive value or negative, and you know multiplying, very careful. So never you do that. So how do you approach this here? We bring it on one side so that we have greater than 0. Minus 2 minus 3 over s plus 5 greater than 0. Okay, we rearrange the LCM be x minus 2 when you do that, the numerator, this times this minus this, it gives the numerator x squared plus 2s plus 6 greater than 0. And having that, remember, we see that the fact that the first part of the equation, x squared plus 2s, is always positive. That's already help us. That's why when you see a question, when they start saying hence, be vigilant. Okay, be very, very vigilant. Because here, we have used that already. So for this to be positive, for this fraction to be positive, this is already positive. So the condition is at the denominator. So for it to be positive, x minus 2 into x plus 5 should be positive. Okay, since we already have that x squared plus 2x plus 6 is positive. Now, being positive, this is a quadratic inequality, which the solution will only be that it is x, okay, in the quadratic inequality here, the solution will be, or let's have it, the critical values, you have negative 5, 2. Which number is less than negative 5? Yes, okay, negative 6. Substitute here, negative, negative, positive. Which number is between negative 5 and 2? 1. Negative. Okay, negative. Which number is greater than 2? 3. Okay, all true will be positive here. So this gives us that our solution set will be, x less than negative 5 union x greater than 2. Is that okay? X less than negative 5 union x greater than 2. Okay, let's look at the other aspect of the question. The Roman 2. 3 cards are to be drawn from a pack of 52 playing cards. In how many ways can this be done? If A, the cards must consist of 2 clubs and 1 diamond. Okay, the cards must consist of 2 clubs and 1 diamond. 2 clubs and 1 diamond. 2 clubs and 1 diamond. Now 2 clubs and 1 diamond will be clubs. We are talking about that 13, diamond 13. Okay, so 2 clubs and 1 diamond will simply be 13 combination 2 times 13 combination 1. We have 1014. And the B part there, let me scroll and read. The B part there, 2 or more cards must not come from the same suit. 2 or more must not come from the same suit. 2 or more must not come from the same suit. Okay, so if you have to do those combinations where 2 must not come from the same suit, 3 cards are to be drawn and 2 or more must not come from the same suit. 2 or more must come from different. So it means we have 4 combination 3 times 13 combination 1 different suit times 13 combination 1 times 13 combination 1, which gives 8788. Is that okay? So that is our solution here. That is the way you are supposed to approach it, because they must not come from the same suit. All right. Okay, thank you all so very much for following up. It is my wish that you practice this. Is my wish that you follow this example, solve this sample GCE 2023, that all the questions have been solved. So you practice them and learn a lot to practice other questions. Do not forget to like, subscribe, share, comment, with my intention being that everybody should be able to pass A-level maths at the advanced level in flying colors. Wishing you all the best. See you in the next videos. Bye for now.